Lesson 1: Graphical Addition of Vectors. Measurement is very important in physics. It is a quantitative information of a physical quantity described by a numerical value and a unit. The numerical value tells us how much, while the unit tells us of what. Without the unit, the numerical value is meaningless. Anything that can be measured is a physical quantity. Physical quantities can be classified as scalar or vector. Scalar quantities are described by magnitude only, while vector quantities are described by both magnitude and direction. The direction of a vector dictates how it is added to another vector of the same physical quantity or multiplied to a scalar or another vector. With this in mind, it is important that we represent vectors properly before doing any mathematical operation on vectors. What's in? Since vectors are specified by both magnitude and direction, they are represented by arrows. The length of the arrow indicates the magnitude of the vector. A vector is a measured physical quantity. The length of the arrow to represent a particular vector must be proportional to the size or the magnitude of the vector. An arrow of any length cannot just be drawn to represent one vector. A dimensional analysis must be made to scale down the vector without changing its magnitude. Scaling down vector is not a direct conversion of unit. Vectors are scaled down when representing them to fit the arrows into the space they are to be illustrated. It is similar to an architect's work when doing blueprints of actual buildings to be built. For example, a displacement vector of 15 kilometers north is impossible to be drawn on this sheet of paper. If we assign 1 centimeter length to represent 1 kilometer displacement vector, the 15 kilometer vector could be drawn as 15 centimeters in the north direction. In this case, the scale is 1 centimeter is to 1 kilometer. However, an upright arrow of 15 centimeters is half the height of the bond paper. Could another scale be used to represent the same displacement vector in a smaller diagram? Yes. If you select a scale of 1 centimeter is to 2.5 kilometers, the represented vector becomes an upright arrow of height 6 centimeters. This is about 1/5 of the height of the bond paper. Take note that the arrow should be upright or pointing to the specified north direction. This is because the given displacement vector is directed due north. Always, the arrowhead or the tip of the arrow represents the direction of the vector.